Hello, everyone. Good morning, good afternoon, good evening from wherever you're watching. Thank you for tuning in again to one more episode here at amazing.com, where we have conversations with influencers and leaders from some of the most innovative companies in the space of cloud native and Kubernetes. That's what we do here. I'm Twain Taylor, editor at amazing.com. And if you like what you hear and see here and you want more, definitely head over to amazing.com, where we've got a lot of articles, we've got interviews, we've got event coverage, a whole lot of stuff, job listings. So definitely go there and check out what's happening. And today I have with me someone from a really cool company that's been around for a while and is really well reputed in the space for just being pretty much the creators of the service mesh. And, unless you've been living under a rock, you know that service mesh is really a huge, huge part of just Kubernetes and what it is today. And so, if this company can, has been there since the start of service mesh, you can bet they know a thing or two. And we have with us Flynn, who's the technical evangelist from Buoyant. And Buoyant is the creator of Linkerd. So Linkerd is this huge open source service mesh project. There's definitely the top two service mesh projects. There's Istio and there's Linkerd. And
we
then
like
of course
to say Linkerd and Istio, but
yeah. Oh yeah. Thanks, Flynn. Got that order right. So yeah, so this is the kind of impact that this company Buoyant and their project Linkerd has had on the space. And so I'm really excited to have a conversation with Flynn today. I'm really having a lot of expectations about things that we're going to learn, and just the kind of the responses that we're going to get. So Flynn, it's wonderful to have you with us. Thanks for joining us.
Thanks for having me. Nice to meet you too.
All right. So, to start off, I just wanted to get to know a bit about you and just, your journey so far with cloud native and specifically service mesh. How did you get into service mesh? Just give us your story just this far.
My path here is probably a little different from what is typical. I actually have been doing software engineering for 40 years.
Whoa. Okay.
Yeah. So
Really
it's been a little while. Things have changed a lot. And I ended up getting into the cloud native world by being the original author of the emissary Ingress API game.
Oh, I didn't know that. Okay.
Yeah, it's I was working at the company that is now Ambassador Labs. We hosted a program where Matt Klein was talking about Envoy as we were leaving. It's kind of like, oh, this Envoy thing seems interesting. Maybe we should see if it'll run in Kubernetes. And that ended up turning into the emissary API gateway. I did that as a software guy for 6.5 years or so, and then ended up something less than a year ago, ended up moving over to Buoyant and trading banging on code for banging on words and teaching people. And that was a fairly natural shift for me, both because I was doing a fair amount of that with Ambassador Labs anyway, but also because if you look at my entire journey over the cloud native part of things, a lot of what I've done has always been trying to focus on the end user rather than on what the implementer needs. And that is a value that is very much shared between emissary and Linkerd. So it was a pretty natural progression there to start going into, all right, well, let me go and check out this different part of the space and pick out a part of the space that resonates well with things that are really important to me.
Wow, really cool. I want to get into a bit more about 40 years ago in the last section where we get to know you a bit. It's really cool that you're one of the creators of emissary ingress. I didn't know that. And we had someone talk about emissary ingress just a few weeks back from Ambassador Labs. So quite fascinating.
That was Dave, right?
Yeah, Dave Sudi. You probably know him.
Yeah, he's a great guy.
Yeah, really cool. So yeah, we'll be diving into a bit of those topics as well, Ingress. Before that, I want to ask about Linkerd itself.
Absolutely.
And its uniqueness in the service mesh space, especially, there's definitely, Istio and Linkerd, the big ones, but there's also a bunch of other options when it comes
Yeah.
to service mesh.
Yeah.
Some new ones like Kuma Mesh, different others that have been cropping up. But Linkerd has managed to somehow, carve out its niche I wouldn't say niche, it's a huge space. Yeah, it's its own, positioning
Yeah.
in the space. What would you say is unique about Linkerd, and why has it had such a big impact in the service mesh space?
The biggest thing that we try to focus on is really operational simplicity, which kind of gets back to what I was saying about focusing on what the user needs. Linkerd is built around the idea that you will do better to choose certain things and do them really well in a way that resonates with your users and lines up with what they need. That will go better than trying to just do absolutely everything and allow it to be complex. So that turns out to really resonate with people. We have literally heard from people who were spending months at a time, repeatedly. We'll hear from people trying to spend months at a time getting some other service mesh working, and then they'll have a proof of concept working with Linkerd in an hour. Wow. One of my favorite stories is an outfit that was hearing about, they were trying to do one of the other meshes. They were hearing things like, oh yeah, well, we got it working part way in 3 months, and it's going to be another 6 months until we get it work all the way. Those guys came to do Linkerd and were in production in 9 days.
Wow.
So
yeah,
that's
pretty cool.
That's the thing that we try to do that we think really separates Linkerd from a bunch of the other ones, is really trying to have the laser focus on operational simplicity.
Yeah, I've heard this before as well. In fact, Dave was the one who actually mentioned this more in one of my interviews with him way back a couple of years ago, about just how easy it is to get started with Linkerd. And that was what really drew him to the project as well.
Yeah, you can, you can spin up, crank up a cluster while we're on the podcast and start Linkerd running, and it'll work.
Yeah, and I think that's really the need of the hour, because you read a lot about just Kubernetes complexity, and there's definitely a trend in the space where there are a lot of different startups who their main positioning is we simplify Kubernetes. So I think there's definitely a need for that. You're going to say
Kubernetes needs some simplification. Yeah. And yeah, at this point I'm more involved with some of the Kubernetes wide initiatives like the Gateway API and Gamma and stuff like that. And yeah, one of the things that the people on those projects are used to hearing me say is, this is feeling like we're focusing too much on the needs of the implementer rather than the needs of the end user.
Okay.
Nobody runs Kubernetes just to say they're running Kubernetes. They run Kubernetes because they have some particular problem they want to solve, some particular application that they want to use. And running Kubernetes itself is that's not an end. That's just a means to be able to do the thing that you really need. So pretty much everything that we put into, if you're an application developer, you're trying to get an application out there to be usable by other people in the world. Basically, everything you have to learn about the care and feeding of Kubernetes is itself friction that is not helping you solve your particular business problem. So to the extent that we can make that better and kind of make Kubernetes get out of your way, that's a really good thing. This is one of the things actually where one of the things that Linkerd really brings to the table there actually is, not only can it be fairly simple itself, but switching your application over to run on Linkerd means that your application developers also get to sort of sidestep a large class of problems. Like, you don't have to have your developers implement MTLS all over the place. Linkerd will just do that for you. Things like that become much easier to do for the people creating the application in the first place.
Yeah, I love how you explain that so simply. And in fact, I think I really love that about, even William Morgan, your CEO and founder, just the way he explains these complex service mesh concepts in really simple ways that, anyone who reads or listens to what he's saying gets it. I find that really fascinating and something that I think Buoyant is really good at.
That's nice to hear. William is extremely good at that. And that is very much something that gets, leaned on heavily at Buoyant. A lot of the things we're doing, some of the things we do are complex, need to be complex, and are going to be complex to explain. But most of those are things that happen at the implementation level. When you're talking about the users, when you're talking about the benefits Linkerd brings in, there really should be simple ways to explain those and simple ways to demonstrate them. There need to be, because if we can't explain them simply, it will be hard for people to use our product.
Yeah. I want to dig into, a bit about this idea of, what you're saying, the difference between the end user and the implementer. Could you just go into a bit more detail into describing for us what that looks like in a typical organization, the kind of roles and responsibilities on each side, their priorities, a bit more detail?
That is a much more complex question than you might think it is.
Okay.
The reason it's complex is that when we say user, that can mean a lot of different things. If you're an application developer, your user will be the person sitting in front of a web browser using your application, right? If you are a service mesh company like Buoyant, when we talk about a user, we're mostly talking about either application developers or platform engineers, that sort of person. So it will be somebody who is either responsible for the care and feeding of a Kubernetes cluster for other people to use, or somebody who is trying to use a Kubernetes cluster to actually get something done, an application developer.
Okay.
In a lot of organizations, and you'll sometimes hear me categorize these as the 4-person startup, that role of platform engineer and application developer might be filled by, those two roles might be filled by the same person. In a larger organization, they will probably not be filled by the same person. And so one of the challenging things here really is to look separately at the perspective of the platform engineer and the perspective of the application developer, because they may be very different. TLS actually offers us a great example of that kind of distinction, where the application developer is likely to care a lot about knowing that they have TLS communications from their client to their application in the mesh, knowing that MTLS is working. The application developer may want to do TLS client certificate authentication in their app. Chances are really, really good that it would be more of the platform role, not the app developer role, that's going to be thinking about, where shall we get those certificates signed? What do we need to do when we have to renew a certificate? The application developer tends to like to ignore things like that. Because again, if you're an application developer, that's just pure friction. What you want to do is solve the business need with your application, not walk into work going, oh, I need to solve, oh, wait, but first I have to rotate certificates. And again, in the 4-person startup, you may not have a choice. You may need to do both of those roles all the time in one person anyway, but in a larger organization, maybe you can separate it. So having a way to separate those two concerns, address the two of them independently, but also not force one to be constantly waiting on the other, turns out to be a really big deal in terms of managing the operational complexity of a product. Another one that we run across somewhat is, well, we run across it a lot really, but it shows up somewhat as we talk about roles. It's important not to miss distinguishing between the role of the implementer of your technology and the user of your technology. So a Kubernetes developer, by which I mean somebody who is working on Kubernetes, the product, has an extremely different mindset from somebody who's just trying to deploy a workload and run it. And one of the places that shows up a lot as a difference is that the developers of Kubernetes and the user of Kubernetes have very different tolerances for ambiguity, for example.
Okay.
If you look at the thing that Kubernetes calls a service, that is an extremely complex thing as an implementer. There are
Okay.
a truly ridiculous number of details that have to go into that.
Mhm.
But as a user, we tend to naturally just think, oh, I'm gonna route traffic to this service and trust that Kubernetes will do the right thing, even though service could mean a name in the DNS, or it could mean a particular resource of type service, or it could mean the pods that are associated with that service resource, or it could mean the IP addresses of it, right? There's a lot of different things it could mean. And as a user, we're completely comfortable with that ambiguity, leaving the implementers to have to deal with making the system do the right thing, even in the face of that ambiguity. And that can be really, really hard.
Wow, thanks for that really detailed response. I think you touched on just so many points there, just the two parts within the organization, as well as just, from a Kubernetes community perspective, how it differs for each of these teams or these people, these roles. So yeah, thanks for that detailed response. I want to ask about just some of the pain points that bring people to Linkerd. When do you see? You mentioned as well, the 4-person startup versus the huge enterprise. Um, and what are some of the signs that the small startup sees, and what are some of the signs that the enterprise sees that tell them, hey, you need to consider using a service mesh. You need to consider something like Linkerd.
It's interesting because there are a lot of different ways that people can end up coming in. Let me lean on a couple of them in particular, though, which are equally applicable to both, although may show up in different ways in those two scales, right? But one of the pain points is actually observability, where it does not take long in Kubernetes to get to a point where you realize that you need more tools to figure out what's going on in your application than you really wanted to set up. So one of the things that's extremely nice about a service mesh is that it gives you pretty uniform metrics across your entire application, and it makes it a lot easier to see where things are breaking or what's going on. And a great example of that one is in Detroit, a guy from Daniel Bryant from Ambassador Labs and I did a demo where we were running both Emissary and Linkerd and an application, and we were doing this live as a demo. And the application was purposefully designed to break a lot. I wrote the demo. It has 3 services interacting, and getting my deliberately broken demo to be only as broken as I wanted it to be required pretty much all the observability tools that Kubernetes and Linkerd and Emissary brought to bear, even given that I'm the author and there were only 3 services. So yeah, debugging is hard, and having the sort of uniform metrics that the mesh can provide can end up being a really early thing that people notice and that can drive them over to a mesh. There's also, and this one is interesting because this is a more important thing in some respects, but I feel like it's not often the first thing that people will notice, which is why I mentioned observability. One of the other really important things, arguably a more important thing, is the security aspect of a service mesh, where it can be extremely difficult to go through and write code at the application layer to know that you are properly doing security in a cloud native application where you no longer have parameters that you can rely on. You have to instead do authentication of each workload and each request. And service meshes make that really, really easy because you install them and then turn on MTLS, and you now have a much, much greater level of confidence in everything without even having to configure it in Linkerd's case. But that may not be the first thing that people notice, especially in a smaller organization. The larger organization, yeah, you may be driven in that direction by compliance, for example, or other other things like that, where it's being called out as a high-level goal for, we have to be able to look our customers in the eye and say that all this is secure and be able to back that up. Whereas in the smaller organizations, since there's only 4 of them in the cluster anyway, that might not be the first thing that they consider.
Mm-hmm.
And both of these topics, just for the record, the observability topic, the MTLS topic, there's a lot of stuff that we've, Buoyant has written about this, or, we do Service Mesh Academy videos on it.
Mm-hmm.
So there's a fair amount about using Linkerd for both of those particular goals.
Mm-hmm. Yeah, the Academy is really cool, something that I just stumbled upon in our recent conversation. And, viewers, if you're really interested in getting to know some of these topics that Flynn is talking about, things like MTLS and certificate management and a whole bunch of other stuff related to service mesh, definitely check out the Academy. Just do a Google search for Buoyant Service Mesh Academy, and you'll see the link pop up there. Some really great videos.
It's actually really simple. It's buoyant.io/SMA is the easy way to get there. Yeah.
Okay, cool. Yeah, so definitely check it out. I think some of the best content, if you want to learn about service mesh, is right there. I wanted to pull a little bit from, get you to talk a bit from some of those talks that you've done at the Academy. You've spoken about observability, you've spoken about MTLS. So, since you mentioned observability as one of the pain points as well that brings people to Linkerd, could you talk a bit about, what's it that Linkerd, how does Linkerd view a Kubernetes stack, or, the cloud native infrastructure different from the purpose-built observability tools like, let's say, a Jaeger or Prometheus, or one of them?
There are, there are a couple of ways that we could talk about that. I'm not I feel like it's not so much the way it views Kubernetes that differs between those as sort of where those tools are focusing.
Mm-hmm.
So one thing that we could talk about is, like if you look at a tool like Prometheus or something like that, the Linkerd Viz dashboard, which is the most obvious dashboard for observability in Linkerd that's always available, assuming you install the Viz extension, which is really easy. That actually uses Prometheus under the hood as a store for all of its data. So yeah, there's not, the question is not so much, does it differ from Prometheus? It's more, what sorts of things are going into Prometheus? And what Linkerd does is since the mesh mediates all the communication that happens service to service within the mesh, and the mesh also understands what kind of request is going over a given pipe, it permits us to put metrics into Prometheus uniformly across the application, talking about, like, we can talk about the number of requests per second, we can talk about the success rate, we can talk about latency, and we can do that uniformly across the entire application without changing the application code at all. And that turns out to be immensely powerful, because you can literally put the service into the mesh and then go open the dashboard and start seeing information about how well communications to and from that service are doing. And it actually is that simple. And because it's all stored in Prometheus, you can also use Grafana dashboards if you want to, or you can go and do all the usual things with slicing and dicing Prometheus data that you want to. So it's not so much that we're trying to replace Prometheus there, it's that we're trying to make certain that Prometheus has a lot of good metrics across the entire application to work with. For something like Jaeger, or the other open telemetry stuff, probably the biggest difference to me is that you actually have to modify the application to get those to work well. Where those work best, in my experience, if you have modified the application to go through and generate traces, and that will give you a nice view across different functions in your application, as opposed to just this workload is talking to this workload. So some of it's going to depend on your tolerance for modifying your application versus your tolerance for not. And obviously, you don't have to choose one or the other. You can use both
Mhm.
of them together very effectively.
Mhm. So is there some setup involved even to get these metrics initially, even the ones that you said, that are based on Prometheus itself? Is there any setup involved to see those in Linkerd?
Not really. The
Okay.
biggest thing you need to do is you need to be aware that if you don't configure Linkerd Viz differently, then it will just stand up its own Prometheus inside the cluster. And if you allow it to do that, then that Prometheus is ephemeral. And if it crashes, you lose all your historical data. So if you're serious about this, you probably want to stand up your own Prometheus and point Linkerd Viz to it, or point Linkerd to it, I should say. And we have documentation about how to do that. That's a completely supported configuration.
Yeah, and I want to talk a bit about MTLS, something that you mentioned a couple of times as well. So could you tell me a bit about MTLS and just Linkerd's approach to MTLS, and if there's anything that Linkerd does that makes it better with how it does MTLS?
I think the most interesting thing there is that it does it without any configuration. You just pretty much put stuff in the mesh and then it immediately starts doing MTLS. Under the hood, at the protocol level, it's just plain old standard MTLS. We don't change the wire definition at all. We don't do any funky custom stuff. We do some interesting things with certificates that are probably worth talking about in this context. The way this works is that there are multiple levels of certificates in the trust hierarchy for MTLS. Each workload gets its own certificate. That certificate is signed by an identity issuer certificate, which is signed in turn by a trust anchor certificate. So you do have to be aware of the need to rotate the identity issuer and the trust anchor. And in an ideal environment, you set this up and you use something like Cert Manager to manage them. We have documentation about that. If you take the 5-minute proof of concept implementation, then it will generate self-signed certificates for you, which work great for a proof of concept. And if you want to go that route, I would strongly encourage you to check out the certificate management with Linkerd Service Mesh Academy, because it will talk about the reasons why you probably don't want to do that and how to do it by hand if you really do want to do that. The managing certificates is important. Cert Manager is the easy way to do it for sure. If we really look at the way all this is put together, one other interesting thing to point out, I think, is that the workload certificates are ultimately based on the Kubernetes service account associated with the workload. So another interesting thing here is that Linkerd is actually bootstrapping from the normal Kubernetes security concept that people already understand, and then using that to turn into a cryptographic identity that you can use to create policies that say things like, oh, so in this namespace, you're only allowed to talk to somebody who's using this specific identity. So you can fairly easily do things like wall off an entire namespace, allow access in from your Ingress controller, allow services in that namespace to talk to the one service they need in another namespace. And you can be as fancy with that as you like. That does take some configuration, but the basics of you install the mesh, you get encrypted MTLS everywhere. There's no configuration involved with that.
Yeah, a trend that I'm seeing, and that's really great, is that Linkerd really integrates well and plays well with these other tools that are kind of like the best at what they do. Like, we're talking about Prometheus for monitoring. We're talking about Cert Manager, certificate management, and obviously emissary ingress for ingress itself, and Flagger, and keep going on. But I like that Linkerd is focused on what it does best, and it integrates with this whole suite of other best-of-breed tools as well. And I think that's really cool.
We really don't want to try to be better than Cert Manager at managing certificates, right? There's no value in that. It works much better for us just to let Cert Manager do what it does, and then we can focus on what we do. And the other tools that you mentioned as well, like Flagger and Emissary and Prometheus and all that stuff. That's ideally the CNCF tools would play nicely together, right? That's kind of part of the dream, right?
Yeah, well, but it can be a pain to just set it up and integrate it. But I think that Linkerd, I think, has got it down with making integration as well easy.
Hope so.
Yeah, and I think that's really cool. I also saw that you had done a talk on route-based policy networking, and I just want to hear a bit more about what does that mean. Sounds really powerful, and policies are something that, again, a lot of people have been paying attention to. If you could talk a bit more about what that means, route-based policies.
So if you look at Linkerd prior to Linkerd 2.12, then we could do policy management at the level of workloads. So we could do things like your web UI workload is permitted to talk to your, I don't know, cupcake tracker or whatever, right? And in 2.12, we added the feature where not only could you talk about workload to workload, you could also say things like the web UI is allowed to do a get on this particular path from the cupcake tracker, but it cannot do a post. It can only do a get, or it can do a post to this other path, things like that. So that basically gives a lot more granularity in what sorts of policies you can create and in what sorts of things you can restrict or allow. In 2.13, we'll be kind of going further with some of this. This is an area where Linkerd, basically the route-based policy stuff is fairly new in Linkerd, and so it's going to be evolving fairly quickly too.
All right.
Yeah. Another thing that's worth pointing out about the route-based policy stuff is that 2.12 was also the first place where Linkerd started to use the Gateway API CRDs. We started to use the HTTP route CRD to talk about route-based policy. And we will definitely be continuing in that direction as well, with trying to integrate a little bit more closely with some of the other Gateway CRD things or Gateway API things. This is one of the reasons that I've been involved with the Gamma project, which is all about Gateway API for service mesh. So
yeah.
And we're supposed to be talking about that in, I think, a little bit less than a month at Service Mesh Academy, actually.
Oh, okay. All right. Neat. We'll keep an eye out for that.
Yeah.
So I want to ask about just just your work with Emissary and Gress before this and Linkerd now, and just being someone who's been deeply involved with both projects. What are some of the things that you've been able to bring, in terms of integrating them better, or anything at all? Anything at all that you've been able to contribute because of your depth of experience in both of them?
I think that, well, first, I think it's important to say that I was certainly more involved with the engineering side of Emissary than I am with the engineering side of Linkerd. Just to be clear. I think that, well, for starters, I should point out that Linkerd did a nice job of integrating with Emissary and really pretty much any other Ingress controller before I got here, which was really nice. But one of the reasons that I knew about Linkerd in the first place was from interacting with the Buoyant folks who were working on documenting exactly how to use Linkerd and Emissary together, and that sort of thing. So stuff that I personally have brought to the table here for, on the Linkerd side is certainly a little bit more limited, a lot more educational content than anything else. I would like to hope that some of the, I'd like to hope that as the engineers have asked me about opinions from the perspective of a user using an English controller. I'd like to hope that they found that valuable.
Yeah.
I've
No, I
certainly
didn't mean
had.
to put you on the spot. Don't worry.
Oh, no, that's fine.
Well,
That's fine. I was also going to say that, Daniel and I, for example, heard from several people that the demo that we did of Emissary working with Linkerd, we've done a couple of those, and we've gotten actually a lot of really fascinating feedback there. So, from people who were like, oh, yeah, this did a very nice job of showing me what these different tools do individually and in concert. And I thought that was really cool. That's something I'd like to continue doing more of that, because one of the things that I certainly have felt for a long time about the cloud native world is that we have a lot of really, really great documentation for experts, and we don't have a lot of really great documentation for people who are just starting out and are trying to learn some of the concepts.
Excuse me. Yeah. Yeah, I think that's a really good point that you make. And I wanted to, even as we wind down the last few questions that we explore, just your work in the space, just CNCF, Linkerd Emissary, and all of these, what do you see, if you're to kind of encourage listeners who are interested in these projects, want to get involved, where do you see some of the biggest needs in these projects where you'd invite people to get in there and, contribute, be part of it?
So this is the point where a lot of people come through and say, oh, yeah, get involved in the code. Actually, if I could make a request, it would be get involved in the docs first, because, oh man, the docs always need a lot of love, right? Yeah, there's a lot of stuff that people can do in terms of improving documentation or writing about how these tools get used, how people can use them, what they're good for. Basically a lot of non-code contributions that can actually make a bigger impact in the long term than fixing a small bug. Although, hey, you want to fix a bug, go for it, right? I'm definitely not saying you should avoid that, but yeah, the non-code stuff often gets missed and can be a huge, huge help. So yeah, that's probably, or, just like there's slack.linkerd.io, there's where that's a great place just to show up, join the Slack and take a look at some of the questions being asked that you could answer or offer feedback or opinions on. That sort of community participation. Oh yeah, I can speak English. That sort of community participation is also a huge win and makes a bigger difference than I think a lot of people realize.
Yeah, it's really insightful. If I can tease it out a bit more, could you share a bit about, kind of what's happening in these projects with the docs? Anything that you see that is exciting in how, some good news that you see about just how docs are being shaped? Anything and all that's happening that could kind of make listeners more interested and want to, be part of this?
The biggest thing that gives me some hope about the docs is that people seem to be starting to pay a little bit more attention as we go, oh yes, please help out of the docs. So one of the fascinating things about docs is that for the most part, the people who work on Linkerd and most open source projects tend to be engineers who are working on it. And the engineers usually will be focused on fixing bugs or writing features, hopefully not writing new bugs. And I've been extremely fortunate to work with engineers who also care a lot about going through and putting together documentation, but they necessarily have to focus on getting the code working first. So, so there are a lot of places where we know that the documentation needs some help and the engineers really want to go in and work on it, but just don't have the bandwidth. So they tend to be really very welcoming and very grateful of people who go through and work on docs, talking about docs in particular.
Yeah. That's really interesting. Good to know some of those details. Winding down, almost the last question.
Mhm.
So Linkerd is open source, and so I was just curious to know, what does Buoyant add on top of the open source Linkerd, uh, and some of the paid services of Buoyant. What are they? How do they
So,
work? What do they
so
add?
we mentioned the Linkerd Viz dashboard,
Hmm.
which is primarily a tool around observability.
Hmm.
And one of the major things that Buoyant offers as a commercial thing is called Buoyant Cloud,
Hmm.
that does a couple of things. One of them is it gives you observability. It gives you much the same observability as Viz, but Viz is limited to a single namespace at a time, and Buoyant Cloud can go and watch your entire application all at once, which turns out to be a big win for problem solving. Buoyant Cloud also, and this is really cool, but again, since we were kind of talking about our observability, I'll talk about that one first. But one of the other really cool things that Cloud does is that we put a lot of effort into trying to arrange for Buoyant Cloud to reduce the friction of Linkerd still further.
Hmm.
So, for example, Buoyant Cloud, you can tell it things like, oh yeah, I want to be running Linkerd 2.12, and it can go through and make that happen. When Linkerd 2.13 comes out, you can go through and tell Cloud, all right, now please make me be running 2.13, and it will go and manage that for you. It can also manage things like, certificate renewals and the like for you automatically, so you don't have to think about it. And it can do a lot of monitoring to actually proactively alert you if it notices something go wrong. So Cloud's real purpose in life isn't just the observability piece. Its real purpose in life is very, very low friction management of your Linkerd installation and applications.
Hmm. Really fascinating. Yeah.
And
Um,
yeah, we'll stick a link to where to get a demo and all that.
yeah. 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 Um, and yeah, also want to give a shout out to the Academy one more time, because I think it's really cool what you and the others who speak there are really doing,
We
just
appreciate
putting
that.
out some great content. Yeah, so I want to encourage everyone who's watching this, if you want a deeper dive into any of these topics, head to the Academy. It's a great place. So with
Head to
that,
the Slack and let us know what you think.
yeah, yeah. So with that, we come to the end of our discussion, the main questions around Linkerd and Buoyant with Flynn. And for the last part, we just have a couple of questions to get to know Flynn a little better. So here goes. So your alternate career, if not for your job in tech. So yeah, you're going to have to probably go back 40 years.
Literally. No, it would be music.
Neat.
Yeah, I had to make a difficult decision on my way out of high school into college, whether I wanted to go off and be a professional musician or whether I wanted to go off and do computing. And
Okay, so what do
eventually,
you play?
I played French horn way back when.
Oh, okay,
And
okay.
yeah, so and I mean, okay, that was my main instrument, right? But like we had pianos and guitars and things like that in the house, so I could
Hmm.
always find my way around with those too, somewhat. But um, but yeah, ultimately it seemed that tech would be a way of having more of an impact on the world, so I decided to go that route.
Hmm. Hmm. Really
And
neat. Wow.
most of the time, I think that was an okay decision. And every so often, certain days, you're like, maybe I should have done the hard thing after all.
Yeah, I play some bass myself, so I can kind of relate.
There's a bass right out there out of the rain.
All right. Um, so yeah, just again, kind of going back for a second question. Tell us a bit about how you got started in, just programming, tech, how it all got started, and the moment you kind of knew, this is what I want to do.
Yeah, we have to go way, way back for that.
All right.
When I was in middle school, yeah, when I was in middle school, I was like 11 or so, and there was some school program where they ran across an old TRS-80 computer. For those of you who've been around long enough, everybody else, you can go look them up. They were ancient 8-bit micro things. But yeah, so I ended up with access to one of those, and like most people in my generation of computing, I promptly started trying to write video games on it. Largely failing, I should point out, but only largely failing, sometimes succeeding. And yeah, that was actually how I got into it, was that I went off and started writing video games. That was my ill-spent youth. I played video games some too, but mostly it was trying to write them. And ended up going in, and I don't actually remember how I got introduced, but I got introduced to a local company who was hunting for people to do basic programming type stuff, and was somehow able to convince them that I knew what I was doing. So I started doing it. So the first language I worked in professionally was actually Pascal, just to make it really confusing. And then I went into C back in the days where if you turned on the optimizer, it might add bugs to your program, and GDB would definitely add bugs to, well, GDB didn't exist, but SDB, the symbolic debugger, would tend to add bugs to your program. So none of us used it.
Wow.
Yeah, it was a different
whole
world.
bunch of stuff that we got to go and research after this. From that. Yeah, really cool though. That's just really early days.
Yeah, it is very interesting to have gone through that much time and to look at what has changed and what has not. For example, all the way back in the 80s when we were compiling code, we would do it by typing make. And you could pick up a make file from 40 years ago and use it today, and it would still work just fine.
How do you get your hands on this computer? The first one you said, right? The TRS, right?
TRS-80. It was from Radio Shack, which doesn't even exist anymore. And
recording studio, right?
Radio Shack was mostly a hobby electronics shop.
Oh, okay. All right.
Yeah. They went bankrupt some years ago. Yeah. This was it was the same kind of class of machine as, like, actually it was a little bit after computers like the Altair and the BBC Microbit and things like that.
Okay.
Yeah. But yeah, solidly back in the 8-bit world, where the first machine I owned was a Commodore VIC-20, and it would, it came with a manual that included the schematics for the whole thing, and talked a lot about the, it was kind of a combination high-level manual, assembly reference, and low-level technical data sheets for everything in the machine.
Oh, way to learn your fundamentals there.
Yeah.
So yeah, next thing is, something that you never forget that happened, or something that you heard, something from a tech conference, something fun or quirky or just memorable.
That is an interesting challenge. I think I'm going to go with the operating systems developer. I think this was OSDI. It might have been Usenix in San Jose, California in 1995, where I got invited to the thing called the Internet Security Cabal World Tour. And I remember walking into the room and kind of looking around and realizing, if this building blows up and everybody in the room is killed, the world will be a different place tomorrow, because everybody who was anybody in internet security at the time was there in one room, which was really quite fascinating. It was a good time. It was a lot of fun to meet some of those people, and be meeting some of those people in the context where you weren't just talking about technical stuff all the time. But it was really fascinating to realize how many people had gotten all packed into one room, and how things could be very, very different if something went horribly wrong, which might tell you everything you need to know about how I tend to think, actually.
You should consider, have you considered, I don't know, writing a book at all on just, Silicon Valley, or, just tracing the roots of computers and tech?
I'd probably have more fun doing it as, like, just a half-hour stage performance or something like that, instead of trying to write a book about it.
Yeah. So as a developer evangelist, you wear multiple hats. I want to ask just which do you see yourself most as? Do you see yourself more as a developer or as a marketer or as a trainer, teacher, or something else?
If I have to pick one, I'd say probably a teacher in this role, but it's really all of those.
Yeah, absolutely.
Yeah. I certainly do consider myself, by trade and by training, I definitely consider myself an engineer. But engineering definitely does not preclude marketing and teaching and being a technologist and being a user interface designer and being a user experience designer and all this stuff, where I think it's really important, especially for folks in tech, to realize that nothing we do is in isolation. And any technology we create, you really must be thinking about, how will this affect people? How do we explain it to people? How do we teach people to use it? All of that stuff is critical to what we do as engineers.
Yeah, really fascinating. I think I was curious to know what resonates with you most, and I really respect that you see teaching as the one that resonates with you most. And I think it's really great that you have a chance to kind of teach with the academy and even with some of the talks that you do. So really cool that you could move from being purely engineering to talking about it as well. That's great.
Yeah, that's been a nice thing.
Really in that. Yeah. The last question for you, your favorite source for what's new and happening in tech?
I mostly cheat massively because I know people who doom scroll Reddit all day long and things like that, and they tend to tell me about things.
Yeah.
So
I think that's the best source.
Yeah, so I have a highly intelligent, optimized network of news gathering sources, or something like that.
Neat. Yeah, that's pretty cool. So with that, we've come to the end of our discussion for today. So thank you so much. Yeah, thank you so much for joining us. Thank you for just sharing so generously from just the breadth of information that the experiences that you've gained over the years. It's been quite an experience just talking to you, kind of getting a flashback of what it was like 40 years ago. And even just that, even now, you're just so on the pulse of what's happening in the space right now. Really hats off to you, just how you're able to combine so much and bring it all together. It was really quite a pleasure chatting with you, Flynn.
A pleasure for me as well. Happy to do it again sometime.
All right. So listeners, with that, come to the end. If you like to hear from Flynn more, check out the Academy. Go to Buoyant and see what they're up to. Check out the Linkerd Slack to get involved with the open source project. So lots that we covered, lots of takeaways for you, whether you're a developer or a platform engineer or a CTO. There's so much that you can take from this talk. So thank you for joining us today, and we hope you'll join us again for more of these in future. All right, take care. All right.